In this problem, we're solving a trigonometric equation. This is another example where using factoring can sometimes be one way to help us get the answer. So it says find the solution set of 4 sine squared a minus 1 is equal to 0 for the degree measures of a in the interval 0 is less than or equal to a is less than 360. That means that we're only letting ourselves go around the circle at most once. Okay, so let's bring this down so that we have a little bit more room to work. So this is 4 sine squared a minus 1 is equal to 0. Excellent. I'm actually going to do a little u substitution now. I don't really have to do a u substitution, but it doesn't hurt, and it might help you to see what comes next. So let's say u is equal to the sine of a. All right, so u is equal to the sine of a. Well, how do I rewrite this then in terms of u? That means that we have 4. Instead of sine squared a, I'll put u squared, and then minus 1 equals 0. Do you recognize the pattern that we have right here? Well, look at this. 4 is a perfect square. U squared is a perfect square. 1 is a perfect square. And we're taking the difference. So this is a difference of perfect squares. And hopefully you remember how to factor a difference of perfect squares very quickly. So let's see here. How do I get that 4u squared? Well, that'll be a 2u. And we're going to have 2u plus 1. And we're going to have a 2u minus 1. That's the pattern when you have a difference of perfect squares is equal to 0. This means that 2u plus 1 could equal 0, or 2u minus 1 could equal 0. Let's solve this for u. So we get u is equal to negative 1. I'm subtracting the 1 and then dividing by 2. So u is equal to negative 1 over 2. Or, here I'm going to add 1 and then divide 2. So this is u is equal to 1/2. Excellent. Now let's bring back the trig. So we're saying u was just filling in for the sine of a. So this is saying that the sine of a is equal to negative 1/2, or the sine of a is equal to 1/2. We can work on this part first. Let's try to find the values such that the sine of a is equal to negative 1/2. If you're comfortable using the special values of the special angles, if you have those memorized, you may be able to reason your way through this by looking at a unit circle and then reflecting in the right way. If that's a lot for you, then let's go ahead and use the calculator. Let's take the inverse sine of both sides. So the inverse sine of the sine of a is equal to the inverse sine of negative 1/2. The inverse sine of the sine of a is just a. And what does the inverse sine of negative 1/2 give us? Let's check. So the inverse sine of negative 1/2 says that's negative 30. So a equals negative 30 is one possibility. There is a little trouble with that, though. You see, they want us to give the answers between 0 and 360. Negative 30 is less than 0. So we need to find the coterminal angle here. To do that, we'll just add 360. So plus, I'm adding plus to this answer, 360. That gives us 330, right? So 330. So one possible answer is 330 degrees. Now let's find it for the sine of a. Really, you should know what angle can we put into a sine and get 1/2. I'm hoping that you do know that. You should have that memorized because it is a special angle. Let's check by using the calculator, though. So this is the inverse sine of the sine of a must be equal to the inverse sine of 1/2. The inverse sine of the sine of a is just a, is equal to the inverse sine of 1/2. Let's see what that gives us. So the inverse sine of 1/2, and that comes out to be 30, something that you should have known because 30 is a special angle. And so the inverse sine of 1/2 is 30. And here we do have two values. There are two values here that will give us what we're after. However, those are not the only possible solutions, right? These are the answers that we get just by taking the inverses. After we take this inverse, now we have to search for the other solutions through reflection. So 330, where is 330? 330 is when you go almost all the way around and it puts you right about there. So this large angle is 330. This, starting from the x-axis, that's 330. This is a sine, and the sine depends upon the y values, which means we have to reflect this through the y-axis, and we end up right there. If this is 330, that means that this is 30. But if this is 30, then the reflection, this is 30. Which means to get the angle that I'm after, that's going to be from there to there, 180 plus 30 more. So 180 plus 30 gives us 210. So the other possibility is that A equals 210. We found this one by using the reflection through the y-axis of this angle. And now we'll do the same here. So this is a unit circle. Estimate where 30 is. I estimate 30 to be right about there. It's a sine, so we have to reflect through the y-axis. If this is 30, that means this is 30, which means the size of this larger angle must be the 180, and then back it up 30, so that's 180 minus 30. 180 minus 30, of course, gives us 150, and so A is equal to 150 is the other possibility. Notice in this problem we found four different numbers that are each between 0 and 360. These are four different angles that will all work if you plug them into the original. They will all come out to give us the desired result. And so the final answer here is that A could be 330, A could be 210, A could be 30, and A could be 150.